All right, today we are starting a new topic. We are going over the attributes of exponential functions, okay? So an exponential function is a function where f of x or y equals some number raised to x, okay? So x is actually your exponent. So for example, you could have f of x equals 2 raised to the power of x, or you could have f of x equals 1/2 raised to the power of x, okay? The number that is raised in the place of where the b is, so the number that's raised to the power of x, that is your base, okay? So here, 2 is my base, okay? Here, 1/2 is my base. The only conditions, it can be any number except your b value has to be greater than 0. It cannot equal 0 and it cannot equal 1. So any number that's greater than 0, so it can't be anything negative, and it can't equal 1. Okay? Anything greater than 0 but not equal to 1. So here's kind of how your graphs would look if 0 is between, or if b is between 0 and 1. So if it's any fraction between 0 and 1, like 1/2, okay, then it's going to be decreasing like this. And it's always going to get closer and closer and closer to some number. In this case, it's 0, but it will never actually touch that number, okay? We'll talk about that in a minute, but that is going to be your asymptote, okay? And then if b is greater than 1, then it's going to be increasing, okay? So still, it's never actually touching 0, but then it's going to be increasing on the right. So once again, this would be your asymptote because it's never going to actually touch that. It's just going to keep getting closer and closer and closer to 0, but never touch, okay? So for these two cases, we would have our asymptote be y equals 0. And that's exactly what an asymptote is, okay? So, an asymptote is a line that your function approaches but will never touch, okay? So since it's never gonna actually touch this line, it's 0, okay? This crosses through 0 on my y-axis, so we say the asymptote is y equals 0. Same thing here, it never actually touches 0, but it's going to keep approaching it and getting closer and closer. So our asymptote is y equals 0. All right, so we're going to look at these examples. Sorry if you can kind of already see the answers a little bit. I just taught the whole thing and then realized I never hit record. So let's do this again. All right, so our first example is y equals 3 raised to the power of x. So we are going to look at the table. We're going to look at our points to see how rapidly they grow. With exponential functions, they grow very rapidly, okay? They're very dramatic. So we're going to start with a -2 because I want y'all to see what happens when you have negative exponents. So 3 raised to the power of a -2. If you'll recall from Algebra 1, when you have a negative exponent, you don't like negative exponents, so you're going to rewrite it as a positive, but in order to do that, you have to move whatever's raised that negative exponent to the bottom. So we're going to have 1 raised to a 3, or 1/3 raised to a +2, okay? So 3 raised to 2 went to the bottom, and the 2 went from negative to positive. And then 1/3 raised to the second power, 3 squared would be 9, so we get 1/9. Then we have 3 raised to -1. So we switch that to be 1/3 to the power of 1. And raising anything to power 1 is just itself, so we just have 1/3. Then we would have 3 raised to the power of 0. Anything raised to the power of 0 is 1. 3 to the power of 1 is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th power is 81. And 3 to the 5th power is 243, okay? So you can see that if we kept go do a -3, -4, -5, -6. We can't make it become a negative because all that happens is your negative exponent just moves to the bottom and becomes a positive, okay? So if we kept going this direction, we just keep approaching 0. We're never going to actually touch it, okay? So our asymptote would be y equals 0, okay? So really we say whatever your asymptote is whatever number is added or subtracted to your base, okay? So since there's nothing, we would say it's plus 0 here. So my asymptote is y equals 0, okay? So if we look at our second example where we have y equals 3 to the power of x plus 1, you're taking whatever numbers you get here, your 3 raised to the power of x, and then you're adding 1 to it. Okay, so let's look. If I have 3, here's the power of -2 plus 1. Well, 3 raised to the power of -2 is 1 over 3 squared plus 1. Well, we know 1 over 3 squared is 1/9. We already know this, right? So we get 1/9 plus 1 is 1 1/9, right? It's whatever we got here, but then plus 1 more. So this one would be 1/3 plus 1, which is 1 1/3. 1 plus 1 gives me 2. So this one's going to be 3 plus 1 equals 4. 9 plus 1 equals 10. 27 plus 1 equals 28. 81 plus 1 equals 82. And then 243 plus 1 equals 244. Okay? So all that changed is now it's just going to keep approaching closer and closer to 0 and then plus 1 to it. So really it's going to keep approaching 1. It's going to get closer and closer to 1 but never touch 1. So 1, positive 1 is going to be our asymptote. So we're going to say y equals 1. Okay? All right, so here's our graph for our first function. You can see how it just keeps getting closer and closer to 0. But if you zoom really far in, you would see that it never actually touches 0 and it never drops below into the negatives, okay? And then if we went and added a 1 here, our graph just shifted up 1, right? Went from crossing my y-axis at 1 to now it crosses my y-axis at 2. It's been shifted up 1, okay? So now you can see it's just approaching 1, okay? So we would have a y asymptote, or an asymptote of y equals 1, okay? But what if we looked at another one? What if we did a 1/2, and then we raised that to the power of x. Now you can see it's flipped, right? Now it's going down from the left, and it's just going to get closer and closer to 0 on the right. So now it's decreasing. And then if I did a, say, -2, it's now dropped, okay? It was crossing my y-axis at 1, and we did -2, so now it's crossing at -2. If I changed it from, see, I was at 1, and if I did -4, so 1 minus 4 would be -3, and now it's crossing my y-axis at -3. So it's just shifting your graph, and now it's approaching -4. Okay, my asymptote would be y equals -4. Okay, there's one more we want to talk about, exponential functions, because you're going to see this now and the next section we do, and it is the letter E. So if you'll see, it says, when I type y equals E, it says y equals 2.718, all those decimals. So E is kind of like pi. It represents an irrational number that just keeps going on and on forever. The numbers never repeat, they just continue and continue, okay? So we say E is approximately 2.72, okay? And if we did e and we raised it to the power of x, okay, it's the same thing, but really you have that number 2.72 raised to the power of x, okay?